Welcome to the deep dive. Today, we're plunging into something with, well, huge potential for real-world impact.
Hmm.
We're drawing from some fascinating book excerpts looking at geospatial technologies, basically thinking about our world spatially
Right.
and how these tools tackle big development challenges, especially, in emerging countries.
That's right. And the source material, it isn't just theory. It really digs into how these tools are actually used on the ground.
Ah, the practical side.
Yeah, looking at everything from the basic tech itself to specific applications and even the frameworks you need to kind of make it all work together.
So our mission today is really to unpack how these geospatial technologies are becoming these, well, powerful catalysts for change, how they're helping solve problems and hit key development goals.
Hmm.
And it all seems to boil down to this idea of understanding location data, where things are, how they connect, how that shifts over time.
Exactly. And what's really striking in the book is how it shows that when you layer different kinds of spatial data together, it doesn't just show you where a problem is. It helps you grasp the context, the scale, how different factors are linked.
Ah, so deeper understanding.
Yeah, leading to much more informed, sort of scientifically grounded ways to find solutions.
Okay, let's unpack this then. Geospatial technology.
Hmm.
It sounds pretty broad. What are the core pieces we need to get?
Think of it like a toolkit, right? For working with geographic info,
Hmm.
the main things the source highlights are geographic information systems, GIS.
GIS, okay.
And there's remote sensing, often. That means imagery from satellites or planes.
Right, looking down.
Global navigation satellite systems, GNSS. That's how we get precise location, like GPS.
GPS and its cousins.
Exactly. And the very long-standing art and science of cartography
Map
making.
cartography definitely feels like the original geospatial tech. People have drawn maps forever.
Absolutely. I mean, mapping has ancient roots,
Yeah.
but it really jumped forward during the Age of Exploration, charting new lands. And that basic human drive, to understand and represent space. That's what paved the way for today's digital geospatial revolution. Now, maps are dynamic, data-rich, interactive.
Okay, so let's zero in on those core tools mentioned in the source.
Mhm.
First up, GIS. How does geographic information systems work as this powerful analysis engine?
Well, GIS is where you bring different layers of geographic information together in a computer system,
Layers?
like
Yeah.
property boundaries, population density, elevation, maybe roads, rivers. You stack them up digitally.
Gotcha.
And then you can ask questions about how these layers interact. The book points to its use in urban planning, for example,
How so?
analyzing land use, looking at transport patterns, demographics, all to plan cities more effectively. Infrastructure, zoning, that kind of thing.
That makes total sense. You need to see all those pieces together to plan properly.
Absolutely. And it's also vital in environmental management.
Okay.
You can monitor resources like forests or water, plan how land's used sustainably, assess environmental impacts of projects.
So like where to protect.
Exactly. Identifying critical habitats for conservation efforts.
And it sounds like it's crucial when things go wrong too, in emergencies.
Yes, very much so. In emergency management, GIS is critical. It helps pinpoint areas vulnerable to floods, earthquakes, whatever the hazard is.
Right.
You can visualize potential impacts, plan evacuation routes, coordinate where resources go in real time during a crisis. The source really stresses how seeing it spatially can save lives.
Wow. And on the practical side, the book mentions setting up a GIS.
Mm-hmm.
It's not just buying software, is it? It's a whole process.
It really is. The source talks about needing careful planning. First, defining exactly what you need the system to do.
Objectives.
Right, then figuring out the data you need, how to get it, designing the database structure, picking the right software and hardware.
Lots of steps.
Yeah, and then the actual work of implementation, testing it thoroughly, and making sure you have a plan for maintenance and updates. It's a significant undertaking. Needs technical skill and institutional buy-in?
Okay, got it. Moving on to GNSS Global Navigation Satellite Systems. Most of us just say GPS, but the source clarifies it's a bigger family now.
Yeah.
How does GNSS work, basically?
So GNSS systems rely on constellations of satellites orbiting Earth.
Right.
These satellites constantly transmit signals, and receivers on the ground in your phone, a car, specialized survey gear pick up signals from several satellites at once.
And that tells you where you are.
By calculating the time it takes for signals from different satellites to arrive, the receiver figures out its precise position on the planet. It's basically using timing signals from space, and it can be incredibly accurate.
And the applications.
Yeah.
Well, you bump into them constantly, even if you don't realize
Oh,
it.
definitely.
Mm.
Navigation is the obvious one, guiding cars, planes, ships, even us walking around.
Yeah.
But it's also completely changed surveying and mapping, getting highly accurate coordinates super fast.
Mm-hmm.
And it provides the ultra-precise timing needed for things like synchronizing power grids or financial transactions across networks.
Precise timing for finance. That's
So
interesting. I wouldn't have immediately thought of satellites for that.
it's absolutely crucial. Ensures everything happens in the right sequence globally. GNSS is also transforming agriculture through precision farming,
How does that work?
applying inputs like fertilizer or water exactly where they're needed in a field based on GPS location and soil sensor data, maybe. Very targeted.
Efficient.
Very. And like GIS, it's essential in disaster management, real-time positioning for search and rescue, tracking emergency vehicles.
The benefits seem clear: global coverage, getting more portable. The source mentions different accuracy levels, too.
It does. Accuracy depends on the specific system, GPS, Galileo, GLONASS, Beidou, and the receiver quality, and how the signal's processed. Standard civilian GPS is typically within, say, a few meters.
Okay.
But with advanced techniques like using correction signals from ground stations networks called cores, continuously operating reference stations, you can get down to centimeter, even millimeter accuracy.
Wow. That precise.
Yeah, vital for high precision surveying, construction, or guiding autonomous vehicles.
It's not always perfect.
Yeah.
Right. What are some challenges? Signal issues.
Signal interference is a big one, yeah. Tall buildings in cities create urban canyons that block signals.
Right.
Atmospheric conditions can affect it. Even deliberate jamming is a concern sometimes. And then there's multipath error,
Multipath.
where the signal bounces off surfaces like buildings or mountains before reaching the receiver. That delay messes up the timing calculation, introduces errors. Urban areas are especially tough.
So how are those challenges being tackled? What's the future look like?
Well, newer receivers are designed to use signals from multiple GNSS constellations simultaneously.
Ah, so not just GPS, but Galileo, GLONASS, Beidou, all together.
Exactly. More satellites in view means better accuracy and reliability, especially when some signals are blocked. Augmentation systems are key too. Systems like WAS in North America or INGNOS in Europe that broadcast correction signals. And there's increasing integration with other tech inertial sensors like in your phone that track movement or computer vision, even AI, to help maintain position if satellite signals temporarily drop out.
So it's getting smarter, more robust by combining data sources.
Precisely, making the positioning more resilient.
Okay, the next tool,
Mm-hmm.
remote sensing and imagery. This is the view from above, right? Satellites, planes.
That's the core idea, yes.
Yeah.
Remote sensing is about collecting data about the Earth's surface from a distance, using sensors on satellites, aircraft, or increasingly drones.
Right.
Satellites like Landsat, Aqua, Terra mentioned in the source carry specialized instruments. They capture different types of information, detailed visual images, surface temperature, atmospheric gases, you name it.
Designing and launching a satellite. That sounds incredibly complex and expensive.
Oh, it's a massive undertaking.
Yeah.
The source outlines this whole multi-stage process starting years before launch. Defining the mission, what exactly does it need to measure? Designing the instruments, the satellite bus itself, building it, testing rigorously, selecting a launch vehicle, navigating all the regulations.
Wow.
Then launch, managing it in orbit, handling the huge streams of data it sends back, even planning for its end of life. It's huge.
And once you get that raw imagery back, say from a satellite or a drone flight, there's work to do before it's useful.
Absolutely. Raw imagery needs processing. Big time. This involves things like geometric correction, making sure features are in their correct geographic location. That's called georeferencing or orthorectification, removing distortions caused by terrain or sensor angle.
Okay, so it lines up properly.
Exactly. Stitching multiple images together seamlessly, that's mosaicing, enhancing the image quality visually, and often classifying the image identifying different land cover types automatically, like this pixel is forest, this is water, this is urban.
Turning pixels into information.
That's the goal, turning raw data into meaningful spatial information you can analyze in a GIS, for instance.
Okay, and finally, let's bring it back to cartography, map making. How does this ancient art fit into the modern digital picture?
Modern cartography is really the crucial step of communicating all this complex geospatial data and analysis effectively.
The visualization part.
Yes, it's not just drawing features anymore. It's about designing clear, informative maps using digital tools. It's about telling a spatial story. You're combining GIS results, maybe satellite imagery, precise locations from GNSS, all onto a map that's tailored for a specific purpose and audience.
So it's the bridge between all that data and human understanding.
Perfectly put. Choosing the right type of map is key too. Is it showing elevation with topography? Visualizing a specific theme, like disease hotspots, or is it for navigation? It's all about selecting the best way to represent the spatial information for the problem at hand.
All right, we've got a handle on the fundamental tools. Now let's really get to the heart of it. How are these technologies actually being used to tackle those big development challenges we talked about, especially in emerging countries where the need and the potential often seem greatest?
Yeah, this is where you really see the power. It gives governments, NGOs, communities, insights driven by data that just weren't possible before. It allows for much more targeted, effective interventions.
Okay, let's take urban planning and infrastructure. Cities growing rapidly. How do these tools help build them better?
Well, geospatial tech is essential for managing that growth. GIS lets planners see how cities are sprawling, map existing land use versus, say, informal settlements. They can analyze population density to predict where future needs will be greatest roads, water pipes, electricity grids.
So planning ahead.
Exactly. And you can, by analyzing satellite imagery, combining it with weather data, soil maps, all within a GIS. Farmers and agricultural agencies can monitor crop health over huge areas,
Wow.
identify areas stressed by drought or needing specific fertilizer amounts, predict yields much more accurately. This is the foundation of precision agriculture, optimizing resources, increasing production.
Makes sense.
And it's also crucial for early warning systems. Detecting potential droughts, pest outbreaks, or crop diseases early allows for proactive steps to prevent food shortages.
Environmental conservation is another massive area. How does looking down from space help protect ecosystems?
Remote sensing is indispensable here. You can track deforestation almost in real time in some cases.
Really?
Yeah, map biodiversity hotspots, monitor changes in gladers or coastlines, assess water quality in lakes, track the impacts of climate change over time.
That's powerful data.
It provides the evidence needed for effective conservation planning, for enforcing environmental laws like spotting illegal logging or mining and managing natural resources sustainably.
And natural resources aren't just environmental.
Yeah,
They include energy, mining, forestry too, right?
that's right. Geospatial data helps find the best spots for renewable energy, like solar or wind farms, by analyzing solar radiation levels or average wind speeds, alongside things like land ownership, slope, and proximity to the electricity grid. All spatial factors.
Okay.
It's used in mineral exploration, identifying geological structures from satellite or aerial imagery that might indicate deposits. In forestry, it helps estimate timber volumes, assess forest health, calculate carbon stocks,
Harvest stocks. Interesting.
yeah, and plan sustainable harvesting while also mapping things like community forest rights or impacts on local livelihoods.
Disaster management and building resilience. Seems like a perfect fit for this kind of real-time spatial info.
Absolutely. When a disaster hits a flood, an earthquake, a hurricane, getting accurate, fast information on the affected area is critical.
Yeah.
Satellite imagery can quickly show the extent of damage. You combine that with GIS maps showing population density, critical infrastructure like hospitals or roads,
And that tells responders.
exactly where help is needed most urgently. Plan access routes, coordinate rescue teams, track the delivery of aid. The source also really highlights using this tech before disasters hit.
For preparedness.
Yeah, creating detailed risk and vulnerability maps, identifying which communities or infrastructure are most exposed so you can take steps to mitigate risks beforehand.
Land administration, figuring out who owns what piece of land. That sounds like a really fundamental challenge in many places. How does geospatial tech bring clarity there?
Oh, it's a huge application area. In places with unclear or overlapping land claims, detailed spatial data from surveying or high-resolution imagery can help establish clear, legally recognized property boundaries.
Reduces disputes.
Exactly. Resolves conflicts, provides security of tenure, and then digitalizing those land records within a land information system, or LIS.
A spatial database for land.
Right. It makes land records accessible, transparent, much easier to manage and update. This is foundational for economic development. Secure land rights allow people to invest, use land as collateral for loans, etc.
Transportation networks must rely heavily on this too, surely, for planning and just daily movement.
Completely. Geospatial tech is used to analyze existing road or rail networks, identify congestion points, plan new routes for efficiency, safety, sustainability.
Hmm.
GNSS, of course, is critical for vehicle navigation, fleet tracking, traffic management systems, and looking ahead.
Smart cities,
Ah,
autonomous vehicles.
yeah. Both rely heavily on incredibly precise, up-to-date geospatial data. Detailed 3D maps of cities, real-time location tracking. It's non-negotiable for managing complex traffic flows and ensuring safety.
Public health is another area you mentioned. How does a spatial view help there?
It's crucial. Mapping disease outbreaks, seeing where cases are clustered geographically, helps health officials understand transmission patterns, identify hotspots, and target interventions.
Like during a pandemic?
Exactly. Visualizing spread, allocating resources like tests or vaccines to the areas most at risk. Geospatial analysis also helps assess healthcare access. By mapping where clinics and hospitals are relative to where people live, considering travel times, it helps plan where new facilities are needed most or how to optimize routes for mobile health teams.
And finally, you mentioned monitoring and evaluation M&E of development projects themselves. How does spatial data help track progress?
It provides a really powerful, often objective way to see what's happening on the ground.
For example?
You can use satellite imagery over time to track the construction progress of a new road or dam, or monitor changes in vegetation cover resulting from a reforestation project, or see if agricultural land use has intensified after an irrigation scheme.
So visual evidence of impact.
Right. Combining the spatial view with other project data allows for a robust assessment of progress and impact, often more efficiently and sometimes more accurately than traditional field surveys alone.
It's really clear that applying all these technologies effectively needs more than just the tools themselves. It needs underlying systems, support, and, of course, funding.
Yeah.
Let's talk about that foundational infrastructure.
Yes, absolutely. None of this works in a vacuum. The source really emphasizes the need for what's called spatial data infrastructure, or SDI.
SDI. Okay, what's that?
Think of it as the organizational backbone. It's the combination of standards, policies, technologies, data portals, and crucially, the human networks, all needed to make sure spatial data is discoverable, accessible, and usable across different organizations.
Oh, this stops data getting stuck in silos.
Exactly. It's about breaking down those barriers so data collected by, say, the Environment Ministry can be easily found and used by the Agriculture Ministry or by local planners, fosters interoperability and collaboration.
Makes sense.
This enables much more integrated, informed decision-making across all sectors. The book also touches on a related concept, geospatial knowledge infrastructure, or GKI.
GKI. Yeah.
It's a bit broader. Focuses not just on accessing data, but on using it to generate actual knowledge and disseminating that knowledge widely to support things like the Sustainable Development Goals, policymaking, etc.
Building all this infrastructure, implementing these big projects. It sounds expensive. How do these initiatives get financed, particularly in emerging countries where budgets might be tight?
Yeah, funding is always a key challenge. It almost always requires a mix of approaches. Government funding is foundational, obviously. Allocating national budget resources for data collection, technology, training people, building institutions.
But that's often not enough.
Often not, especially for large-scale national initiatives like building a full SDI or major sector-specific applications. So other sources become crucial.
Like international partners.
Yes. International aid and donor funding play a huge role. This comes from organizations like the World Bank, regional development banks, various UN agencies, or bilateral aid programs from individual countries.
And getting that funding involves
Putting together strong proposals that clearly align with the donor's development priorities, demonstrating the potential impact, showing plans for sustainability, engaging stakeholders, the whole package.
Are there other avenues besides government and aid?
Definitely. Public-private partnerships, or PPPs, are increasingly important.
Sure.
Leveraging private sector expertise, technology, and sometimes investment to help deliver geospatial services or infrastructure more efficiently. Think data providers, tech companies working with government agencies,
Right.
multilateral development banks like the World Bank, Asian Development Bank, African Development Bank are also major players, providing large loans and technical assistance for big projects.
What about other, maybe smaller sources?
Well, the book mentions philanthropic foundations. Some focus on specific areas like environment or health, where geospatial tech is relevant. Research grants, both national and international, can support innovation.
Mm.
Even newer models like crowdfunding for very specific community-level mapping projects might play a role. And don't forget knowledge exchange partnerships, accessing expertise or technology through collaboration, which has indirect financial value.
Any others? Cost recovery.
Yes, for certain types of geospatial products or services, developing cost recovery mechanisms where users or beneficiaries pay a fee can help cover ongoing operational costs and improve sustainability. Think specialized data products or mapping services. And specific climate or environmental funds are another potential source if the project addresses those issues.
So it really takes a blended finance approach, aligning with national plans, building partnerships.
Exactly. No single source usually covers everything. It requires a strategic mix, strong justification, and demonstrating value for money.
This deep dive has really hammered home just the immense potential of geospatial technologies. They're clearly not just technical tools in a box. They seem like fundamental building blocks for tackling some of the world's toughest development challenges, offering that data-driven clarity, enabling truly transformative change across, well, almost every sector imaginable.
It's absolutely true. And as the source material really underscores, unlocking that full potential takes more than just buying the software or the satellite imagery.
Right.
It demands, forward-thinking leadership. Sound policies that actually encourage data sharing and innovation, not hinder it. Investing in that underlying spatial data infrastructure we talked about.
The backbone.
The backbone, and crucially, a strong commitment to using this powerful data responsibly. That means paying close attention to privacy, data ethics, security.
That's critical. So the journey involves constantly monitoring impact, pushing for geospatial thinking to be integrated into policies, and really fostering a culture where spatial data is seen as a valuable shared asset for development.
Well said. It's an ongoing process.
So as we wrap up, here's something to think about. As we consider the future of development, particularly in emerging countries, what previously unseen spatial pattern might be waiting for geospatial technology to reveal it, and how could its discovery change everything? Thank you for joining us for this deep dive into geospatial technologies for development. We hope this gave you a valuable new perspective.